Welcome to day 5. Today what we're going to do is we're going to talk about graphing a system of inequalities. We graphed single inequalities in the last chapter. Now all we're going to do is graph two inequalities at the same time and find the overlapping shaded region. Couple of reminders as we get going. Anytime that you have a less than symbol or a greater than symbol, remember that we are going to use a dashed line, or what we call a broken line. Anytime that you have a less than or equal to or a greater than or equal to, you're going to use a solid line. Okay, and then from there we have to talk about the shading. So let's go ahead and take a look at example 1. In the first inequality, we have it's written in slope-intercept form. So I'm going to start down here at -5, put my point, and since my slope is -3/4, I'm going to go down 3/4. Okay, I can also go up 3/4 to the left, and I've got a couple of points. Since my inequality is a less than, I am going to use a dashed line or a broken line through my points. I'm going to extend it as far as possible because I do not know where the other inequality is going to be. For the second inequality, I am going to use the idea of a T-chart because it's written in standard form. So if my x value is 0, that gives me a y value of 2. If my y value is 0, that gives me an x value of -6. So now I have a -6 on the x-axis, a +2 on the y-axis. Up 2/6 is the same thing as up 1/3. Okay, since my inequality is less than or equal to, I am going to use a solid line. Alright, so now, as we talk about the shading, a couple of things that you can do. You can test points to find the correct solution. So a lot of times, if I go back to my first inequality, if I wanted to determine whether or not to shade above the red line or below the red line, I could test the origin. And when I test that origin, if I plug it into my inequality, I would end up with a 0 is less than -5. That's a false statement. So that means I am going to shade on this side of the inequality. Okay? I could also use the idea that since it is written in slope-intercept form, less than means shade below the line, which we ended up doing anyway. For the blue one, if I test the origin, again, test 0, 0, if I plug in 0 for the x and the y, I end up with a 0 is less than or equal to 12. That is a true statement, so that means I shade where the origin is, and I get a situation like this. Okay, so that means that my solution area is actually just this, where the two sets of inequalities or shaded regions overlap. This is the area in which points will work both inequalities. Okay? Up here, none of the points will fit either inequality. In the red, it'll be true for the red one but not the blue. And here it'll be true for the blue but not the red. And then down here, where I shaded with the black, it'll be true for both. Okay, so that's our region that we are looking for. Alright, let's go ahead and do a second one. In my first inequality, it looks like it is written in slope-intercept form, so I start at -5. Slope of 2 up 2/1. Okay, I can also go down 2/1. It's a greater than symbol, so I am going to use a dashed line. Okay. This time I'm going to check the origin or use the idea of greater than and figure out that I am going to shade on this side of the line, so something to kind of keep a heads up on. So after I graph the next line, I will know the one region that I need to shade. So for my second inequality, I know that my y-intercept is 3. Down 1 over 3, down 1 over 3 gives me my points. I can also go up 1 over 3. Less than or equal to means a solid line. Okay, and if I were to test the origin or use the idea of less than or equal to, I would get a true statement, which means I'm going to shade below the line. So that means I want above this red, but then below this blue, which looks like it's pointing towards this one region, and that means this is the only region I need to shade. Okay, so, and the origin is contained in it, and the origin, we said, works for both inequalities. Alright, what I would like you to try and do is do example 3 on your own and see what you can come up with. Okay, I'm going to go ahead and move on to example 4. And the reason why I have example 4 is it gives us two different inequalities. The very first one is written in point-slope form, so a nice reminder of point-slope form. My starting point is going to be at 4, because the opposite of x minus 4, and then 5, because of the y minus 5. So I go to 4, 5, which is right here. Okay, my slope is negative 2, so down 2 over 1. I can also go up 2 over 1. I'm going to use a solid line this time, because it's a less than or equal to. If I plug in the origin, I would end up with a negative 5 is less than or equal to a positive 8. That is a true statement, so that means I'm going to shade towards the origin. Alright, the blue line says y is greater than negative 1. A y is greater than negative 1 is going to be a horizontal line through negative 1. Okay, and it's going to end up being a dashed line because of the greater than symbol. Greater than this line would be above it. If I test the origin, I get 0 is greater than negative 1, which is true. So I want above the blue line and where the origin is in reference to the red. So that means this is my shaded region. Okay, any point in this region will work for both inequalities. And just to kind of show what I mean by that, if I were to choose the point, say, negative 1, 4 here, if I were to plug in a negative 1 for x in my first inequality and a 4 for my y, I would end up with a negative 1 is less than or equal to a 10. That is a true statement, and all points in this region will work. If I also plug in the point negative 1, 4, I get 4 is greater than negative 1, which is also a true statement. So notice that this point works for both. Alright, let's go ahead to page 2. Alright, in the word problem, the goal here is to figure out the number of type A questions and the number of type B questions that we could answer with our given constraints. And the given constraints mean you're allowed 60 minutes and you can answer you cannot answer more than 16 questions. Okay, so our goal is to figure out how many type A and how many type B we can answer. So when we go to define our variables, x is going to equal the number of type A and y is going to equal the number of type B. Okay, so when I create my system of inequalities, I am going to create one dealing with the minutes. So that means that if it takes 3 minutes for a type A and 6 minutes for a type B, and I'm allowed 60 minutes, 3x plus 6y has to be less than or equal to 60 minutes. For my number of questions, well, the number of type A questions plus the number of type B questions has to be less than or equal to 16 questions. Now there's some basic understanding that we have to have, and that is that even though it doesn't say it in the paragraph, you cannot have a negative amount of questions on a test, so x has to be greater than or equal to 0, and y also has to be greater than or equal to 0. And you can see when we take a look at our graph here that it is only in the first quadrant, and there's a reason for that, and that is that you can't have a negative amount of questions. Alright, what we're going to do is we're going to graph this. Okay, and I talked about this earlier in the chapter, that when we go to graph this, it's always a good idea to figure out our x and y intercepts of our inequalities first so that we could figure out how to scale it. So when I do the x and y intercepts for the minutes inequality, if x is 0, y is 10, and if y is 0, x is 20. Okay, 3 times 20 is 60, and 6 times 10 is 60. When I go to do my second one, my x-intercept is going to be 16 when y is 0, and my y-intercept is going to also be 16 when x is 0. So this tells me, based upon what I see, is that my x-axis has to go up to at least 20, and my y-axis has to at least go up to 16. So we could probably scale them about the same. Next, what I should do is I should count the number of squares on my graph so that I figure out how far I can go in terms of the number of boxes. Since our graph has 20 boxes going in both directions, I basically could probably just go up by ones. So I'll do that. Okay, so on the x-axis, we're just going up by ones. So we got our 2, 4, 6, each box is 1, 8, 10, 12, 14, 16, which I needed, 18, 20. And then same thing going this way. I'll stop it and get this done. Alright, now that I have it labeled, okay, I can go ahead and create my lines. So from my first chart, it looks like I need to go from 10 on the y-axis to 20 on the x-axis. That means if I'm going down 10 over 20, I'm going down 1/2. So down 1 over 2, down 1 over 2, down 1 over 2, all the way across. Okay, that gives me a better indication and more exact points. Okay, and when I go to do the second one, I'm going from 16 to 16, which means I'm going down 16 over 16 or 1 over 1. So I can just go through each corner of a box, down 1 over 1. Okay, next, since I can test the origin, and the origin is right here, if I plug it into the top one, I would get 0 is less than or equal to 60. If I plug it in the bottom one, I get 0 is less than or equal to 16, both of which are true statements. So I want to shade below both lines, so that means I only want this region here. Okay, this region would be above the one, so that's bad, and this one would be above the other, and that's bad. Okay, so we don't want those. Alright? Alright, the last part that it's going to ask you to do is, assuming that our graph is correct, state 3 combinations of type A and type B questions that would comply with the above constraints. Okay, so that means I could do, say, something simple like 2, 2. If I did 2 type A and 2 type B, that's going to work because that's less than 16 questions. Okay, so 2 plus 2 is less than or equal to 16, and 3 minutes per type A and 6 minutes per type B. That's 6 plus 12 is going to be less than or equal to 60 minutes. So I just have to come up with 3 other possibilities. I could do, say, 6 and 2. Okay, I could do 4 and 5 if I wanted to. So any one of these points, and there's a lot of points I could choose from, is going to fit the bill. The reason for the 10 points and the 15 points in the question is that's what we're going to eventually call our objective question, okay, or our objective function, and we're going to talk more about finding the maximum and the minimum later on in the next section. So just giving you a heads up on that, and also to let you know why we did not use those numbers. If you have any questions, please feel free to bring those to class.